Dr. Shneider from Columbia, who's been treating a lot of our ALS patients. So welcome.
Thank you, Lauren. Thank you, Laurie, and good morning, everybody. I want to start first, in case I run out of time, which I always do, to thank Stan and the n-Lorem staff for their extraordinary commitment and dedication to ALS patients. Silence ALS has become a major program and taken up a lot of n-Lorem time and resources, and it is greatly appreciated. I'm here to give you an update on the Silence ALS program and remind you first that in 2025 ALS is still a fatal neurodegenerative disorder selectively involving motor neurons in the brain and spinal cord, often associated with a related disease called frontotemporal dementia. 30,000 to 40,000 Americans suffer from ALS today, and the large majority of these patients have no underlying genetic cause of the disease, no family history, so-called sporadic disease. But in about 10 to 12% of cases, there is a known pathogenic variant in an ALS gene causing the disease. ALS is a genetically complex disorder, and this really gives you a sense of the history of ALS gene discovery over the last 30 years. The first of these genes discovered was SOD1 in 1993, and nearly 30 years to the day after the gene was described as an ALS gene, an antisense oligonucleotide, an ASO therapeutic, was approved by the FDA for this rare, ultra-rare form of ALS, developed by Biogen, by Ionis in partnership with Biogen. Tofersen was approved in 2023. Ionis was at the time under Stan Cook's leadership, and a team led by Frank Bennett, Richard Smith, Don Cleveland, Tim Miller, and many others contributed to this extraordinary milestone in ALS history, the first therapeutic to alter the natural history of ALS, and the first, I think, to really demonstrate the power of ASO technologies to benefit ALS patients. We moved this technology further into ALS. In my laboratory, working with Ionis, we developed an antisense drug called jacifusин to treat a rare genetic form of ALS caused by mutations in the gene FUS, fusin sarcoma, associated with juvenile onset disease. And we were able to show through an investigator-initiated multi-center open-label case series published earlier this year that this ASO was first safe, but also resulted in a dramatic decrease in neurofilament light, a marker of neuronal injury. And also this was associated with a dramatic reduction in FUS levels throughout the nervous system and a decrease in the burden of FUS pathology that is a hallmark of this disease. In one extraordinary case, we were able to demonstrate that this decrease in NFL was associated with a really remarkable, really unprecedented functional recovery in one young patient with a very aggressive form of FUS ALS. This really gives us great hope for the promise of this ASO. Based on the safety and efficacy data that we were able to provide, Ionis, now in partnership with Otsuka, sponsored a global phase 3 clinical trial of this ASO, which has now completed enrollment, and we hope in a year or so that this trial will read out, and our hope is that we will have a second example of an ASO benefiting a rare genetic population, ALS population. We wanted to move this ASO technology further to treat genetic forms of ALS, but rare as they are, SOD1 and FUS ALS are relatively common forms of ALS, and there are many other genetic ALS subtypes for which a commercial program is simply not possible, either because there are just too few of these patients with these mutations, or as in the case of a gene called TAR-DBP, major focus of Silence ALS, a critical regulatory protein that can't be targeted, and we believe a non-allele selective manner. These genes like this require an individualized approach that really simply is not feasible in a commercial effort, and this of course lends itself very well to the n-Lorem platform. So in 2021, shortly after n-Lorem was founded, we established Silence ALS, an initiative to discover and develop individualized investigational ASO therapeutics for ALS patients with ultra-rare pathogenic mutations. This was and remains a partnership between n-Lorem and our center at Columbia University, but as you can see, that partnership is growing. The idea initially was to create an infrastructure that builds on n-Lorem's nonprofit precision medicine platform, bring together stakeholders from academia and nonprofit groups to address this need. We wanted to leverage our disease-specific knowledge at our ALS center, but throughout the ALS community, identify symptomatic carriers of these rare mutations, but also asymptomatic carriers who bear a great risk of developing ALS. And we wanted to treat these underserved ALS patients as close to their symptomatic conversion as possible, ideally even before symptoms arise. And as Stan has said, our goal overall is to create knowledge, experience, efficiencies that will inform our understanding and approach to all forms of ALS, including the non-genetic sporadic forms of the disease that share a common biology, and other related disorders like FTD. So over this year, we've done a lot to build our Silence ALS program, including establishing a Silence ALS network under a charter agreement that is meant to establish a network of physicians, institutions treating ALS patients with n-Lorem Silence ALS ASOs. Membership in this network allows investigators to leverage the resources and infrastructure of Silence ALS and to enable broad access of these potentially disease-modifying therapeutics. Our goals are multiple. One is to establish collaborative sample and data collection, analysis, and sharing, to build and share central resources, including a biorepository of samples collected in treatment, standardized protocols and regulatory documents for IND submissions and IRB submissions that would make these programs much more approachable to our network members, building network infrastructures, including committees focused on scientific, clinical, and regulatory issues, advocacy, patient education, and fundraising, of course, which is not unimportant. We're focused on joint publications of collaborative efforts, and we will be holding regular academic meetings to share our experiences, share our knowledge, and to promulgate this opportunity. And we have already engaged with a number of ALS centers throughout the United States and internationally, and this network is growing and will grow over the coming year. ALS is focused really on mutations amenable to ALS therapeutics, really those caused by a dominant mechanism, including toxic gain-of-function mechanisms, which I think is the majority of cases that we focused on. We have a major effort focused on TAR-DBP, a major player in the pathogenesis of ALS, and also CHGHD10, but we have earlier programs focused on Sanataxin, Nexin A11, Profilin-1, KIF5A, and other genes. This is a brief summary of our program. We have, through Silence ALS, already nominated 60 cases of the nearly 120 patients that we are actively engaged with. We're following an additional 59 patients who are or will soon be eligible for a Silence ALS program. The large majority near majority of our patients have TAR-DBP mutations. Nearly 50% of our patients have one or another pathogenic variant in this gene, but about 10 to 15% of our patients have mutations in CHGHD10, Nexin A11, Profilin-1, This is a growing subset of our patient populations. I have a lot to say about the TAR-DPP program, more than I have time to say today, and maybe next year I'll focus on it. But today I thought I would focus on our efforts in CHDH10 ALS. About 10 years ago, pathogenic mutations were identified that cause a multi-system neurodegenerative, and other related disorders, including ALS and frontotemporal dementia. Two mutations, R15L and S59L, were particularly associated with ALS and FTD. And we have amassed a team of scientists and clinicians that are focused on the normal role of CHDH10 and the role of mutant CHDH10 in the pathogenesis of ALS. These are colleagues at NINDS, at Cornell, at Columbia, and abroad, including my friend and colleague Patrick Veit at Bonn, whom I'll mention in a moment again. A few weeks ago, we published a preprint. This is a study led by Derek Narendra and Justin Kwan at NINDS, characterizing a very large German-American family with an R15L mutations. Preprint and the references here characterizes the clinical neuropathological and biochemical features of this disorder. Encourage you to read the paper, but the highlights of the paper really is it summarizes and presents a large 7-generation pedigree with at least 68 affected members, which to me makes the point of the extraordinary burden that these ALS families bear with generational risk of developing this fatal disorder. The allele is highly penetrant, 70 to 80% penetrant, meaning that if you have the mutation, you have a 70 to 80% chance of developing ALS. And what's been extraordinary looking at this family is the stereotyped nature of this phenotype. They have a rare a variant form of ALS, which we call flailed arm syndrome or brachial amyotrophic diplegia. And this suggests selective involvement of the cervical spinal cord, which we have gone on to demonstrate through neuropathological studies of members of this family, where we've shown subtotal loss of motor neurons throughout the spinal cord, but relative sparing of the lumbar segments and preferential involvement of cervical segments, which we're very interested in studying further. These studies show prominent CHDH10 protein aggregation, as is shown in these two images, and interestingly, an absence of TDP43 pathology, which distinguishes CHDH10 ALS from the vast majority, greater than 97%, 95% of ALS cases that have TDP43. We have used samples from these patients, including fibroblasts and iPSCs that you've heard about this morning, but as well as knock-in and knock-out mouse models to study the consequences of these mutations on CHDH function and its role in ALS. And a lot of work, I'll summarize by saying that our review of the literature and our own data suggested a toxic gain of function mechanism, and also importantly, a tolerance for haploinsufficiency or reduced D10 function. And this allowed us to approach the ATTC with a plan to pursue a non-allele selective ASO strategy for these patients. And n-Lorem went to work and did what they do so well, which is to develop this ASO, NL-CHDH10-001. This is a 20 base pair gapmer, similar to many of the other ASOs that you will hear about. This is a non-allele selective ASO, meaning it doesn't distinguish between the mutant and non-mutated form of the gene. We went to work at Columbia to apply this to the large family that I described, and we first met through our friends at Project ALS, the Weber family, and I know they're watching out there. So a shout out to them. And the Webbers have part of this extraordinary family history. We began by treating a single member of the Weber family with this ASO at Columbia, and soon expanded the program to treat all 4 affected siblings with this ASO. And we began to extend our efforts to second and third cousins and to more distant cousins. We're now treating 10 and soon 11 and 12 members of this extended family in what I think really is a remarkable effort. This is where these patients are treated. I've listed 15 patients here. Most are treated at Columbia University. One unrelated patient treated at Mayo Clinic in Jacksonville, and there's several patients now pending treatment at Mayo Clinic in Rochester, Northwestern University, and hopefully in other sites. Remarkably, we've traced this gene back to Germany, where this family was originally from, and my friend Patrick Veit will hopefully very soon be treating members from the German part of the family with this same ASO, and what will be our first international effort, the first of many, I hope. All of these patients have been treated with a standard protocol, including the same safety assessments and outcome measures as mandated by the FDA. They begin with an induction of 3 doses of 50 milligrams of this ASO, and then they escalate to 75 milligrams for 3 doses, and ultimately to 100 milligrams final dose. The most important thing I can say, I think, about this program so far is that after 50 individual doses of this ASO, I can say the ASO is safe. We have seen no drug-related adverse events in this cohort. The one woman who died sadly a few weeks ago died of complications of disease, we believe unrelated to this therapeutic. But what we've also been able to show, as Laurie mentioned, is we've seen a really dramatic decrease in levels of neurofilament light in these patients here normalized to their baseline. We've seen 50 to 60% reduction of NFL in these patients, even at the submaximal dose of 50 and 75 milligrams. And I would just say that this is, to my knowledge, only the 3rd ALS drug after tofersen and J-Fusin, the FUS ASO, to achieve this level of neurofilament reduction in an ALS population. Real question is whether this biomarker success will translate into clinical success. I'm a little more perhaps reluctant to claim that at this point. CHH10 is a very slowly progressive form of ALS, and we'll need time, I think, to demonstrate clinical efficacy. But we're committed to following these patients over the next couple of years to demonstrate clinical efficacy and to bring this ASO out to the benefit of larger numbers of these carriers, to address really the extraordinary threat that this mutation poses to this large cohort. So I'll end by just saying that the Silence ALS program is growing. Our intention is to scale our initial efforts to involve more patients with additional ultra-rare, nano-rare gene mutations. We will expand nationally and internationally through our growing Silence ALS network and gain efficiencies in both time and cost that I think will allow us to help more people. We're building a library of Silence ALS ASOs, and what we've already found is that we can apply these ASOs to newly nominated cases, saving a great deal of time that our patients don't have. We're focused on identification and characterization of pre-symptomatic carriers, again with the idea of getting these ASOs into our patients really as early as possible, even before symptomatic onset, because I think that's our greatest chance, gives us the greatest chance of clinical benefit. Many of the genes we're focused on also cause frontotemporal dementia in these same families, and we're extending our efforts to FTD. And as Stan and Laurie both said, we're applying the knowledge gained through the treatment of these ultra-rare cases to the large majority of ALS cases with shared underlying biology that don't have pathogenic variants, but we believe our efforts have greater relevance to ALS patients. I thank you again to the n-Lorem team and to the members of my lab. This is maybe the most important slide. Patients, families, clinicians, if you believe you have a patient who might benefit from the Silence ALS n-Lorem program, please reach out to Ellie Harrington, our genetic counselor. Very happy to just discuss with you, and with great thanks to the many people who make this possible.